let's get started. I'm curious about the audience. I know a lot of the audience that was registered, and some of you I don't know. So I'm curious, how many people think they already understand like how Ethereum works and what it does? Okay. And how many people are like technical side and want to know about technical stuff? Okay, all right. I'll try to gloss over some more deep technical stuff. I think some of that's important to the narrative as to what's happening in Ethereum right now, because a lot of the narrative in the press and in probably the rooms of your engineering departments and CIOs deciding what technology to use is around, does this technology meet my needs? Is it approaching a state where it meets my needs? So I'm going to address some of that a little bit and try not to get too into the weeds, though. So firstly, what is Ethereum? I think most people don't really know what that is. They think maybe it's something kind of like Bitcoin, but different, but pretty much the same thing. It's another cryptocurrency. That's one thing that it is, Ether. Ether exists in order to fuel the smart contracts that sit on top of the Ethereum blockchain. So it's an Ethereum virtual machine, is one of the main differences between it and something like Bitcoin. It's basically an application platform that enjoys properties of decentralization. So there's no central locus of control. There's no central actor that necessarily controls the operation of the entire system. The system is an epiphenomenon. It's an emergent system that is determined by the actors that underlie it or comprise it. And that virtual machine runs smart contracts, which are pieces of code that are specifically designed to run on this decentralized virtual machine, or sort of a decentralized global computer is one way to think about it. That token, Ether, is necessary because if we, say we just made this big global computer that was high trust, it could run financial applications, anyone can use it, why don't I just write my movie collection to it? The reason you don't want to do that is because it would be extremely expensive, probably cost billions of dollars, and that's why Ether exists, because you need to pay a little bit of Ether every time you store something or write something or compute something using this shared global resource that is the Ethereum virtual machine. There are also token standards that sit on top of this, so ERC20, 223, 721. ERC20 is probably the most famous one. It was actually invented by someone at Consensus. And this is, when you hear this new token launched, or this new token launched, pretty much all of those, actually 95% of those are ERC20 tokens on top of Ethereum. This basically means on Ethereum, you can write one line of code that makes a new token. It could be a stock of your company. It could be, X equals 5 million shares. It could be X equals 5 million things that represent an ounce of gold. It can be whatever you want. But this is one of the primitives that you can construct things out of using Ethereum. And finally, decentralized applications are kind of the point of this whole thing, right? I could have really simple decentralized applications like I have a token that represents an ounce of gold and I give it to you or you give it to me. That's a really simple application. Bitcoin is also another really simple application you could make with this. It's just a token that you can give to each other. You can also do really complicated things like the New York Stock Exchange implemented in a way that's decentralized and open source and sits on top of this network. You could do much more complicated things than that if you want. So these 5 things kind of comprise the functional elements of what Ethereum is, and I think most people lose a little bit of that granularity. So it's also important to distinguish, a lot of the phrasing I just used is about public Ethereum. It's about the public network that we call it mainnet, sort of like what the Bitcoin network is. It exists out there, anyone can permissionlessly join it. This is public Ethereum. There also emerged along the way, as people looked at the problem space that was addressable with blockchain technology, a desire to address the blockchain enterprise ecosystem, right? And enterprises have different requirements. They have things like privacy, they have things like compliance standards, they have things like transaction throughputs that have to use certain types of encryption or whatever. And so there started to emerge the desire to sort of break off a version of this technology that is an enterprise-ready version of it. And so way back 2014 is when Vitalik proposed the white paper for Ethereum. It actually launched 2015, 2016, and Consensus was already getting a lot of inbound interest from governments, central banks, Fortune 50 companies, asking us to help them understand this technology and how it would affect their business and build things with it. And eventually, we, along with Microsoft, JP Morgan, Santander, a few other partners that were founding members of the EEA, We had the cocktail reception for them here last night in the space in Davos. We ended up forming with them this thing, the Enterprise Ethereum Alliance, and I think there were something like 13 founding members. As of today, there are, I think, more than 550 members. It says 500 on this slide, but pretty much every Big Four, Fortune 50, most of the cutting-edge governments that you can think of that want to be on the front ends of technology are all members of this. So they came together to put together some work around, how can we apply this technology to our specific industry? How can we also work together to donate back resources, research, human capital, time, et cetera, to make sure this technology remains adaptive? Because this is, in the eyes of, I think, most of the members of the EA, the most promising technology that exists to meet their needs. On the other hand, you have sort of walled garden approaches like, are produced by companies like IBM, for instance, which sort of produce vendor lock-in. You have other platforms as well that just don't really have the developer community, but for a number of reasons that I'll talk about in a little bit, a lot of large industry players and governments, when they're choosing a technology to build on, they thought that Ethereum was probably the way to do it. Does anyone remember, I think the audience is old enough, Steve Ballmer from Microsoft shouting sweatily on stage, developers, 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 right? Right, and the reason why he was shouting that is because he knew that having a huge developer community around your tools was really the way to get adoption, right? What are the kids in dorm rooms writing on? What are people writing on after they go home from work at night? What's the cool thing that they're downloading? Probably an open source project, probably not something that requires a huge vendor contract to develop on, right? They're developing on the open source, they're developing on the stuff that they're in chat rooms talking about. That's why, in our estimation, we have at least, that number is probably a little old, at least 300,000 developers in the Ethereum community, adding about 30,000 a month. As I mentioned, when you hear about a new token that exists on blockchain, when people say that, they literally mean they built it on Ethereum. There are some others, but 95%, if you go look at the top 95, the top 100 tokens on CoinMarketCap, 95 of them are Ethereum tokens, those ERC20 tokens. And if you look at the blockchain, you can identify about 2,000 decentralized applications that are deployed right now to the public Ethereum blockchain. So we know that developers are extremely important. At Consensus, we build a lot of developer tools, and I think that's one of the things that has really seeded this market. And if you ask a cool kid, what they go home at night and work on, I bet one of them has downloaded one of these tools that falls into this metric. So what do we want in a blockchain, right? Why is Ethereum different than other blockchains, put another way? And I think Ethereum rises up to meet the design goals of what, in my personal view, we want, and I think in a technologist view, what they want. So I would advance, we really want three things. We want scalability, we want privacy, and we want to default to openness. And so when people say, well, I can't have a public blockchain, I can't connect to the internet, I can't be on public cloud, I can't be on Amazon, they're not saying that they can't do that. They're saying that their chief risk officer is nervous because they haven't understood yet the scalability or privacy concerns and the compliance concerns that go along with that. So I think, also when people say they want something like a private blockchain, what they're saying is, well, I heard that if I do this private instance of Hyperledger, it'll go 1,000 transactions per second, and I want that to go that fast, but they don't necessarily understand that then what? How do you connect that thing to the larger internet? So openness, I think, is a little more nuanced, and I'll go into in a second. But we talk about this. I think Vitalik Buterin came up with this. Vitalik's the founder of Ethereum, or the inventor of Ethereum, rather. The scalability trilemma. Basically, scalability, security, and decentralization are three things that you want from this technology, right? And a bunch of other companies, a bunch of other technologies have made a compromise, right? So Hyperledger Fabric, for instance, is right in here, the DLT space. This is right between security and scalability, but they've sacrificed decentralization in order to achieve that, right? On another extreme, you have things like AWS Lambda and Google Cloud Functions. These are like serverless, stateless applications. They have no security, but they're decentralized and scalable. Ethereum, and the slide got a little crushed. It says Bitcoin over here in the green. Ethereum and Bitcoin have managed to stay way over here. And what they've done in their current iteration is sacrificed a little bit of scalability in order to make sure that they're decentralized and secure. Those things go hand in hand with each other in a protocol like this, because if you have centralization in something like a blockchain protocol, what that means essentially is that you lose the security, or you lose the security and its hardness to certain types of attacks on it, right? So if I'm sending $1 billion, right? Let's say I have some ERC20 tokens, or let's say I have some Bitcoins or some Ether, and it's literally $1 billion, and I want to send it to Lee. And you're welcome, Lee. And so in a centralized system where there are known actors that control it, let's say there are 21 people that all are confirming that transaction. All I have to do is go to those 21 people and stop the transaction. I just say, convince those 21 people, either by force or by being charming or whatever it is, I convince them to not confirm the transaction, then it doesn't get confirmed. However, in something like Bitcoin or in something like Ethereum, I would have to convince thousands of people that are geographically diverse all over the world in order to do that. And part of the power of this decentralization, part of the power of this whole platform comes from the fact that there is no centralized locus of control. So that is an extremely important design principle that Ethereum did not want to give up, at least at first, in its construction. You have other things that have also made that compromise, like for instance, EOS. I think that's EOS right there. They've given up decentralization. EOS is exactly what I just described. With 21 individuals, essentially, can decide whether to censor a transaction. Doesn't really meet the design goals of an enterprise client. Doesn't meet my everyday case of sending Lee $1 billion. So it's not good enough. So what else can we do? How can you improve scalability while maintaining decentralization, right? This is what I was just describing. DPoS, that's the system that that EOS is based on. Other people have tried this. The problem with this is you get tragedy of the commons situations, like theoretically, those 21 people could be removed if they behave poorly by voting. The problem is in practice it doesn't happen. It actually took several days to launch EOS because they couldn't even get the token holders. Only 10% of them needed to be online and voting in order to actually launch the network. Took many days to actually launch the network. And then in practice, BitShares was another previous iteration of a DPoS system. It stands for delegated proof of stake, meaning that you have those delegates, like 21 people deciding. Generally less than 10% of people actually vote. And that is not really the behavior that you want. And theoretically, it would be great if everyone voted and immediately they voted out a bad actor, but it just doesn't happen. So that's not that great. People leave tokens on exchanges too, and then the exchanges would have to vote. Collusion happens. Actually, there was a bunch of evidence of collusion between block producers who censored votes on EOS. This is a while ago. And then right here, actually, in this little red box, then EOS mentioned, well, we'll have to fix the decentralization that didn't work by more centralization, and we'll take all of our tokens that we own and vote out the other people, so we'll control it. So it really is just is a mess. It doesn't seem like an elegant solution to the problem. The better way to do it, in our view, and the way that Ethereum is approaching this, is a multi-level system, right? So the base layer, what we call L1 of Ethereum, that's the thing that I can send Lee $1 billion with and not think about it. I know it's going to happen. I know that it's not going to be censored or changed or get messed up. What I sacrifice for that security is a little bit of speed, right? And I think I'll go into some slides later where I think we get to thousands of transactions a second at least on that first layer, L1. But not all transactions need the same security as me sending Lee $1 billion. Some transactions just need the security of a like on Facebook, or me sending an in-game object in a video game to someone else over there, or moving a character in a video game or something. There are different use cases, different security requirements, and therefore different network topologies, different techniques that we can use. And so in the Ethereum worldview, and in my personal worldview of how this is going and how it will go, we're going to have an extremely high trust layer 1 protocol that looks a lot like Ethereum right now with some additions to it to make it faster. And then we're going to have just a plethora, we'll have a Cambrian explosion of different layer 2 protocols that sit on top of that are aligned for different use cases. And that might be settlement in something in a bank. That might be something for a social network. That might be trade finance settlement. And those all have different requirements, different trust security requirements, different architectures that support them. So solving the scalability trilemma, I think, as I mentioned, we have Ethereum here, and we have it connecting to things like the Loom network, which is a layer 2 protocol, things like Plasma, which is a design principle for layer 2, things even like AWS Lambda and Google Cloud, things that already sit inside of your existing infrastructure. So we have this sort of Ethereum emerging as an interconnection, an interwoven fabric that is the base layer, the high secure, high trust, but relatively low throughput base layer to which everything else is connected. Privacy. So a lot of people say, well, blockchains are public and you can see everything on them, so why don't I, how could I ever put my business on that? A bunch of things are emerging right now that solve that problem. JP Morgan's Quorum is one way to do that. This is an enterprise-focused version of Ethereum that essentially allows private payloads of transactions in Ethereum. Consensus helped work on this a little bit. There's a bunch of work being done on this as well. Our Pegasus client is doing some work on this. ZK Snarks and ZK Starks are encryption technologies that allow you to basically put private data on the blockchain and only have the other counterparties be able to read it. You can also store things off chain, et cetera. But so my point is, there are a lot of privacy mechanisms in play, and it's not really something that I think is concerning in the long run. It's just how are we going to choose the right set of technologies for the right use cases? I don't know. Computers suck, I hear. All right, there we go. Default towards openness. So the other problem is that a lot of the systems that have emerged, and if you look throughout the history of the internet, a lot of the systems that emerged were walled gardens, right? Walled gardens are easier, they seem safer, it's easier to convince your chief risk officer that you're not gonna go to jail or be uncompliant if you have this thing that's walled off from everyone else. But the problem with that is you end up with companies like that. These are the last walled garden companies that I remember, right? And they thought that they could build this self-contained thing. But it turns out what was really interesting was not intranets, it was the internet, right? It was the fact that you can interconnect those networks. And you might have some private computation that you want to do behind your firewall. Most companies do. Any given bank probably has lots of back-end systems that have no need to be public-facing. But they also have a lot of systems that do need to be public-facing, like interfaces into exchanges, interfaces with their customers' mobile banking applications. Whatever it is that the public needs to interact with or can interact with, having that open is the interesting part. Just having the computers behind your firewall is not the interesting part. That's not what caused the explosion that is the internet revolution, right? And so Ethereum currently is the only platform able to do that, to have the backwards into your network-facing parts, as well as the open-facing parts. Let's talk about Enterprise Ethereum for a minute. As I mentioned, the Enterprise Ethereum Alliance, over 500 members. This is really interesting. This is the Enterprise Ethereum Architecture Stack, which we put out along with the EEA a few months ago. And this is essentially a set of technologies that can work together to achieve both the desires of any enterprise or government that wants to build a system for themselves, as well as compatibility with the public network, right? So this is things like pluggable different wallets, pluggable key management, pluggable different ways that the blockchain can sync with each other, pluggable different token standards, identity systems, etc. And so this, I should actually go back a couple slides. So this is basically this idea. You can have Ethereum here. Ethereum can be sitting on the public network. It can simultaneously be plugging into things that are already normal in your computer systems, like AWS Lambda, like OpenShift, like Azure Stack. So it can sort of sit at that nexus between an internal, normal computer system, as well as the new external permissionless innovation style technologies that you want public facing for your company, right? There's a little better image of it. This is pretty cool. This is implemented in our client called Pegasus. This is our Ethereum 2.0 client. So if you're interested in this, I encourage you to check that out. We have lots of enterprise applications that are real. Sometimes people just question, what's real and in production that people use Ethereum for. These are some real things. JP Morgan already has done some real transactions with their Quorum. We built for a long time ago, actually in production, provenance tracking for minerals for BHP Billiton. Santander has been doing cross-border payments, interbank payments in their sub-banks for quite a long time. So lots of interesting applications. I think this is just scratching the surface, though. But I just need to have that for people that question, well, are you actually using this for anything? So here's what gets me really interested, honestly, is the emerging public network applications. DeFi stands for decentralized finance. So this is already stuff that's live, that's happening right now. Maker, DAO, is a DAO, which stands for Decentralized Autonomous Organization. No one controls it. DAO has these things called CDPs. They're smart contracts called collateralized debt positions. And what you do is you take Ether, and let's say I take $1 million of Ether, and I stick it in this smart contract on Ethereum. What it does is then it spits out the other side this thing called DAI. So you might hear people say Maker DAI. DAI is an ERC20 token that represents a US dollar. Just by definition, it represents a US dollar. And essentially what that is, it's a collateralized loan, right? So I gave $1 million, it spits out $500,000 of this DAI dollar token. That's pretty amazing, because normally that would require a lot of lawyers, it would require a bank, it would require settlement, it would require pieces of paper that I signed, all kinds of stuff. And if that collateral ends up going down in value such that I'm not collateralized enough, I need to go re-collateralize that. I need to fill it back up. And if the value of the collateral goes up such that I'm over-collateralized, I can take out more. So it automatically rebalances itself. It'll automatically liquidate if it gets too low in collateral. So that's a whole swath of the financial system that is pretty much disintermediated by a few smart contracts on Ethereum. It also interestingly creates this dollar stable token, different than other stable tokens you may have heard of, like USDC, which are created by regulated entities. They're audited, they hold that number of dollars in a bank account, et cetera. This is literally just achieves the same thing with no human being controlling it, that's mathematically provable to be collateralized and backed by something. DX Exchange. This just launched a couple weeks ago. It already exists. In partnership with NASDAQ, you can take NASDAQ-listed stocks, put them on the Ethereum blockchain, fractionalize them, so I can buy like a trillionth of a stock. 24 hours a day it trades. No lawyers, no brokerage accounts, no anything. It's just a smart contract sitting on Ethereum. Interesting what that is going to do to the world. Compound finance. I can take my Ether, stick it in a smart contract. I think the rate's something like 7%, and other people will borrow it from me, all mediated by the smart contract. I make 7% per annum interest, just lending out my Ether or a bunch of other tokens, or maybe even in the future my trillionth of a Apple stock or whatever it is. And so, also no humans involved, automatically done already. This is Uniswap Exchange. This is a decentralized protocol. It's literally just an open source project. No company, no human being that's controlling it or pressing an on and off button for it. Literally just a peer-to-peer exchange mechanism. Any asset that's digital for any other digital asset. I think it has something like, maybe $2 million US in it right now in the smart contracts, but it's growing at about 30% a month right now. It just launched. Meridio is a platform that actually is one of the consensus portfolio companies. This is a platform that allows you to tokenize real estate. So normally, if an individual investor, even an accredited investor, can't afford to buy a significant chunk of a $500 million building in Manhattan, but they might want to, you can fractionalize, tokenize access to that. allow greater liquidity, greater access to different kinds of investors, make it a lot easier to administrate, so I don't need a piece of paper every time. Maybe I want to buy $1, $1 of a $500 million building. That would not be worth the paper needed to do it in a normal transaction, but here it's the same as someone putting in 50 million. It's the same amount of work. So all decentralized finance applications, and this is already live. It's already real. This isn't someone making up sci-fi stuff. If you ever want to know what cool stuff is happening on Ethereum that's already being built, I would check out this Twitter account. It's called Built on Ethereum. For whatever reason, some press outlets do not like to highlight the fact that pretty much everything that you hear about that's interesting on blockchain is actually an Ethereum project. So this Twitter account, what it does is just takes every news story and points out which ones were built on Ethereum, which is pretty much all of them. And this is nice because the second one happens to be a consensus project that we did with WordPress, where blockchain tools and our platform Civil will be integrated into WordPress. So check out this Twitter account. Let me take the picture. All right. So how do we get all of these things together? I think this is my vision of what it really looks like. It even looks like this right now, but zoom forward a year. This is the ultimate vision of what I think happens, right? Ethereum, mainnet Ethereum, public Ethereum is a fabric that interconnects all of the other systems, right? This is the economic interconnection point, the high security layer one, where I can send Lee $1 billion and not worry about it. And then we have things like Pegasus, which is our Ethereum 2.0 client. The beautiful thing about something like Pegasus is that it can sit simultaneously on the public network of Ethereum and simultaneously also deploy private networks that have totally different network topologies and different security and privacy characteristics. So let's say there's a private network where JP Morgan and Santander want to do some settlement of some trades or whatever it is. They can set up a network using the Pegasus technology that does exactly what they want, meets all their risk characteristics, is as fast as they want, et cetera. And then let's say there's another thing. Let's say JP Morgan, or actually more interestingly, let's say ING has a network like that, and ING would like to get maybe some decentralized finance applications. Maybe it would like to use a decentralized application that lets it bet on risk, like a prediction market that's sitting over here. It could pull that sort of risk out of this decentralized world, put it through mainnet Ethereum, package that into a financial product and offer it to their customers, right? Similarly, you could imagine maybe JP Morgan wants to use something that emerges out of here. Maybe they want to invest in a building on Meridio and offer it to their customers, or maybe they want to. Maybe they're getting better rates on compound than they would get in other lending scenarios, and they want to offer that to their customers. Only with an architecture like this can you actually get the simultaneous kind of state and information transfer from inside of these networks into there. And then I think, so that's layer one. And then you have layer two as well, like Loom, which I mentioned, which is a high throughput, maybe thousands of transactions per second already system that allows you to run things like games, social networks, et cetera. Comgo, I just wanted to point out too, this is a commodity and trade finance system that we're building with some other partners that will essentially allow insurers, financiers, participants in trade finance to all run on the Ethereum blockchain. So imagine you had multiple of these. Maybe there are 5 different companies that look like Comgo. They want to communicate with each other across this interconnected fabric. I think this is what the world looks like in 1 year, and it's what it's starting to look like right now. So just a couple cool examples, and I'll stop in a moment. I think governments are already starting to adopt this. Uport is our project for identity on blockchain. The government in Zug, the canton of Zug, which is kind of nearby here, has already used this to issue to their citizens a blockchain ID. We're helping Smart Dubai, which is the smart city office of Dubai, work on their land registry system as well as other government services there. Asset tokenization is already real and it's happening. Meridio, as I mentioned, is tokenizing real estate. This is an Andy Warhol piece called 14 Electric Chairs that was recently fractionalized and sold in, I think, 1,000 different pieces. So that's happening as well. And then other aspects of the trust, that's, what else goes in that web of interconnected entities? I think things like open law, which are programmatic but legally enforceable law, like smart contract laws. Balance, which allows you to account for money as it moves around those networks. Things like UJO, which are non-monetary but still require trust, are also part of that vision of the world. So I think it's all coming together. This is basically, for all the technical people that are interested, this is basically the timeline of what's happening with Ethereum. Quadratic sharding is going to give us thousands of transactions a second on that layer 1. A bunch of layer 2 stuff is happening as well. Casper sharding and Plasma are the names of the things that will allow that layer 1 to scale a lot. I can go into detail more on those. Some people call those Shasper when you add it together, but that sounds weird. Vitalik said, please can we just call it Serenity, because Shasper sounds really weird. And we end up with a world that looks like this, with layer 1 Ethereum, things like at layer 2, like Plasma chain, and even more chains connected to it. So that's it. Thank you very much.